finishing these up with the normal distribution. We have one example, and then looking at what if we want to go backwards and figure out what our minimum sample size needed to be. So a college admissions director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, the mean age is found to be 22.9 years. From past studies, the standard deviation is known to be 1.5 years, and the population is normally distributed. Construct a 90% confidence interval of the population mean age. So we know that our sample size n is 20. We know that our sample mean X bar is 22.9, and that our population standard deviation from a previous study is 1.5, and our C is 0.9. Okay, so because we know our population standard deviation, okay, we can use our normal distribution table. So our critical value, Z of 0.90, is going to equal 1.645. And remember that came from the bottom of your table 4. Okay. So we have our point estimate, X bar. So we need to find E, our margin of error, which the formula, let's review that, is ZC times the standard deviation divided by the square root of n. So if we plug in what we know, we have 1.645 times 1.5 divided by the square root of 20. So we plug that in and we round to the same as our sample mean, we get approximately 0.6. So to find our interval, we're going to take our point estimate, 22.9, minus 0.6, which is less than our mean, which is less than 22.9, plus 0.6. So if we subtract, our lower interval is 22.3, and then our upper interval is 23.5. And remember, I'm okay if you want to write that as a parenthesis set instead of an inequality. Any questions with that one? Okay, so it's just the only difference between this and what we did yesterday is that rather than just listing out each of what's over here on the left, you actually have to pull it from the problem, okay, which is a lot of what you guys did in Unit 5. Okay, so the other part with confidence intervals is we could use it to find a minimum sample size. So that way we can better know how many we need to survey or find information from. So finding a minimum sample size to estimate the mean, given a C confidence level and a margin of error E, the minimum sample size N needed to estimate the population mean is, and this is our formula. It's the same formula we use for E, just rearranged. If sigma is unknown, you can estimate it using S, provided that you know that there's at least 30 numbers. And the key thing here is that you have to round up. No matter what, if it is 5.1, that's your minimum that it can be, which means 5 does not work. So you're always going to have to round up to the next whole number. Okay. So if we look at this example, determine the sample size required if you want to be 99% confident. So C equals 0.99. So I'm going to go ahead and pull that from our table. Z of 0.99. Our critical value is going to be 2.575. That the sample mean is within 2 units of the population mean, given that the standard deviation is 1.4. So we know sigma is 1.4. And then the other thing we need to find for our formula is our E. This one is kind of hiding in here. So it says within 2 units. That is your margin of error. So E equals 2. All right, so plugging this in, N equals the quantity of 2.575 times 1.4, all divided by 2, quantity squared. So if we plug that in, we get approximately 3.249, and then we're always going to round up. So our sample size minimum is 4.